Next up, we have Brian Bockelman, who's going to talk about the second bird in our flock.
All right. Uh, the microphone. So, uh, as Marone was saying, that the pelican is the young one of the crowd. So just like young children, you don't count their age and years, but in months. So I was doing the math, and especially since yesterday I got the notification from NSF that the annual reports now due. I think we're at 21 months. So not quite 2 years yet. Uh, I'm at a little bit of a disadvantage because all the technical stuff of what's going on in Condor is in Todd's talk at the back end. So I'm going to try to sneak in a few technical details and a few higher level things, a little bit about who we are and what we do as well. So we'll see if we guys get your breaks. Uh, if I have to think about what the Pelican project does, the project itself, not necessarily the OSDF service, I think of us as delivering a software platform allows us to deliver data to throughput computing. So project as a whole may have some non-throughput computing pieces as well, but considering what event we're at, I'm going to focus on those for today. We take that software platform and we use it to support the OSDF that Frank just talked about. So just like you have Condor, a software suite that powers the OS pool, Pelican, we think of as the platform that powers the OSDF. Uh, so what do we mean by deliver data? Well, when I'm in front of non-technical audiences, I like to make the analogy of a Netflix for science. You don't have to train, for the most part, people how to use Netflix. You have this idea of you find the thing you want and you hit go. And we want to start doing something along those lines for how you access scientific data. You find the data you want, and you're able to start streaming it. Now, this is hopefully a little bit more of a technical audience. So what I like to say in front of technical audiences is we want to actually be something more akin to Cloudflare, right? So Cloudflare is, I think, the largest CDN in the world. And this kind of this analogy takes maybe the more operational or the infrastructure side. We want to provide a service that helps you scale up access to your storage. So in the same way, Cloudflare may protect your website from a denial of service attack or help you manage your millions of users. This is where we start to get into more high throughput computing. We want to be able to help manage how we distribute data out to your workloads, and we want to help make sure it doesn't overwhelm your storage infrastructure. In terms of the science that the OSDF then enables, there are some of what I'd call the big kids, the really large collaborations that really push us. And I'll give an example a little bit later of maybe where some of these collaborations even push us to topple over. LIGO is one of the big collaborators that are always asking more and more and using it in clever and interesting ways. So they're a great example of one of the big scientific collaborations. But one of the things I've learned over the many years of collaborating with the throughput computing community is it's somewhat easy to scale up. But the real trick in any of these software is scaling down. So I would hope that we put just as much effort, if not more effort, into what can we do within Pelican and the OSDF for individual PIs. So it was great to actually have Kurt here today, and he'll give a talk about how he used it for his project. It's easy if you have the ability to draw in from all these individual universities to make something work. You can develop expertise and specialization. When you're just one small group, that's when you really know the quality of the software. So this is where we want to go within Pelican. Can we enable and get individual PIs, individual small groups up and going? So when I think about the OSDF, and every so often you get a call from the funding agency saying, "Can you take everything that you do and all the complications and everything that you talk about over hours and hours of PowerPoint talks and condense it down to a single slide?" So if you try to put our whole life into a single slide, this is somewhat what we came up with. So we think of what we do in terms of being able to uh, enable people to share their data. We think of in terms of managing the load, particularly for object reuse. So can we make sure that your data gets out in a way such that it doesn't overwhelm your object store? We think about being able to fuse data from across different object stores and through a common namespace. And increasingly, we want to work more in terms of staging and explicitly managing the data within the ecosystem, because that's where we start to differentiate from, say, just Cloudflare. Uh, as Frank said, we move about 140 petabytes over a 12-month period, give or take a little, depending on which 12-month period you look at. And again, size and scale is maybe more of a function of your budget and how many caches or how many gigabits of hardware you can put in. The thing that I'm really proud of is that translates to about 3.5 billion requests a second, or requests total over that 12-month period. So on a busy day, we're delivering on about 100, 120 requests a second. Uh, there's always a real danger in giving live demonstrations. The next most dangerous thing besides giving live demonstrations is doing a PowerPoint animation on a version of PowerPoint you don't control. So we're going to see what's happened here. So, okay, it hasn't moved around too much. Um, to illustrate kind of how the components work, let's take an example that actually Harsha, where's Harsha? He'll be talking about, I believe it's tomorrow. Um, let's take an example of you are an Earth systems researcher maybe doing some climate work. You're living today in a Jupyter notebook, and you want to do some sort of data analysis that both includes data from the NCAR Research Data Archive. So this is stored somewhere in Wyoming. And you want to pull in some data, maybe results of simulations, that is in AWS's open data platform. So we're going to start off with our black object and a red object, and we want to get it into our Jupyter notebook in order to do our science. So here's Harsha's object. It has a name of some sort, an NCAR, and it has a name of some sort within AWS. So here's the components of our system as far as the logical components as far as the scientist goes. And now we introduce the different pieces of the OSDF. So we have a central piece that's managing it all. It knows about the namespaces. It knows about the top level things and all the services that we provide, but not the individual objects. And we have a name for these objects within the OSDF ecosystem. So that one at NCAR has this prefix of NCAR. And for the one that was at AWS, it has its own AWS Open Data prefix. So now Harsha invokes the Pelican client. This is where animation gets fun. And it says, get this object from NCAR. It reaches out to the namespace and says, here's an object I'm interested in. Can you provide me a service name that will give me this object? It says, sure. You can go to this particular layer within the content distribution system. Now, within the cache, if the data was already there, it's easy, right? It can just return it. But in this case, we decided that the cache also has to go off and find where it is at in-car. So it also talks to the director, says, where can I find this object's origin? Redirects it to in-car, and it can flow back through the system, eventually delivering the object into the notebook and keeping a copy in the cache for future use. You have the same thing that goes on analogously with AWS. And you end up with both objects there. And now Harsh's notebook can then visualize and produce the correct graph. All right, so those are the high-level components. A quick tour through some of the technical pieces. So within the project, we support 4 different clients. We have a command line client, so you can just type it and say Pelican object get and hit enter and have the object downloaded. We have a Condor plugin that's becoming increasingly impactful for particularly the OS pool. We have a Python library, and that's how we connect to the AI and data sciences ecosystem. And we have some simple web browser clients. You can click a button and download the objects. Within these, for the command line client and the Condor plugin, we've been introducing end-to-end checksumming. So before we have this object in the object store, it passes through the ecosystem, eventually getting to onto the disk of the client. And now the client, as it passes through, will calculate the checksum. And if it's contacting a object store that also keeps its own copy of the checksum, it can also request that it be pulled through, and we can make sure that if you're downloading the full objects, we know that at least the checksum of what was delivered here is the same that the object store says it's right. Now, does the object store have the right copy of the checksum? That's an interesting question for a different day, but we can now at least compare those two. We are making some changes in authorization. So we have credentials that the client presents to the service to get be authorized to get a particular object. And if it's not there, historically, we've just forwarded that credential along to make sure that we can get it from the origin as well. And this has a problem that we couldn't actually distinguish cache-based accesses from client-based ones. So now the federation actually gives a separate credential, a separate authorization to the cache, and the origin can say, I only will talk to you if you can prove you're appropriate client asking for the object or you're working on the client's behalf, and you can prove that you're a cache within the ecosystem. And this protects the caches from maybe enthusiastic clients that bypass them. Justin will be talking about that later in the week. We have lots and lots of changes within storage backends. But the thing I'll point out here, maybe that's most important, is we're working to provide better protection against the object store of what I'll call overly enthusiastic clients, that we can't always stop the clients, but we can make sure that they don't impact your throughput. And there's a whole lot of work for us to do in terms of opportunities for integration with HTCSS. We're trying to improve on all the monitoring that we showed last year for how the client looks and records its overall opportunities or overall experiences. This is work Jason presented last year. Patrick's going to do a deeper dive on this year. And we now wake up every day and ask William, our lead operator, William, was it a good day in the OS pool for OSDF or was it not? Patrick will go a little bit deeper in that, and I'm running short of time and don't want to eat up the coffee break, so I'll skip over a couple of things. Again, we're having increasingly broad community for both throughput and non-throughput cases. One of the big changes that happened the last year is or actually last month, is we now have all of NCAR's research data archive integrated in the OSDF. And it's been fun that once they changed all their download links to be powered by the OSDF instead of directly at their web server, we started seeing a new client pop up in all our monitoring, and that is Mr. Google Web Crawler. So for the first time now, Google has also seemed to have discovered the OSDF, and almost immediately, here's just from a single cache, we're seeing hundreds of megabits at least of traffic going through from NCAR. So one last thing. So we mentioned the Condor Project's 40 years, the OSG Consortium is 20 years, the Pelican Project is 1 and will turn 2 in a little bit. If you look at how we operate and what we do, you have this little logo that we put on the CHTC website. We are all about translational computer science. We're not interested in the sort of computer science where we come up with a clever idea, we publish the paper, we do the prototype, we publish the paper, and throw it away and wait for the next clever idea. For us, the real important part is going from the lab all the way out to the communities and building this feedback loop so we can understand how to make our research, our ideas, our innovations better. Pelican is the new kid on the block, is really trying to rapidly build out the community. The community includes individual users, includes UW-Madison campus folks, includes collaborations, includes people maybe not even doing as much high throughput computing or just trying to share data. The one thing I want to point out is the community is you. So everyone here really is an essential part of this project. And to make sure that you provide feedback. So as we go off into the coffee break, as you talk to folks throughout the rest of the week, if you see any of these people in these pictures, corner them. Whether you're an OSDF user already or you think that this could potentially help your workloads, corner us, talk to us. At some level, we kind of set the infrastructure layer. We set kind of the thing that sits below the user interface. So we really relish the opportunities to hear more from you. And hopefully we will have many more birthdays for Pelican in the future. Thanks. Any questions?
Hi, Brian. I'm wondering, do you want Google indexing the OSDF pool that you mentioned? I mean, what is it actually discovering? It's a bunch of binary data, right? I mean,
what does Google do with NCAR's data? That's a good question for Google. I would say I don't mind it.
yeah,
You know,
it's only hundreds of megs or
yeah,
something. So
the interesting thing here goes back to that slide about throttling or management, right? We are lucky in the OS pool case, we control both the client and the workload manager and the service itself, and we can help manage the end to the end. One of the interesting questions is, what do you do when you have clients that you don't manage, whether it's they produce a lot of load or they have a use case that doesn't involve a lot of reuse and potentially thrash all your caches. So at some level, it's good exercise for us to make sure we do manage well, we do have some multi-tenant capabilities and that one user that we don't particularly know well doesn't negatively or overly negatively affect the rest of the infrastructure. So is Google doing useful science by crawling NCAR's data? I don't know, maybe it could be doing some really cool stuff.
so NCAR's data is all open data then?
Yeah,
too?
so this is all
Oh,
particularly,
okay.
yep, open data. Yeah, if you, wherever that clever link is, but if you go to type into Google, say, NCAR Research Data Archive, and you go click through links, you will, in the end, be an OSDF user yourself.
I see. Thanks.
The interesting, a challenge. All the challenges are interesting. Is what happens if the object in the object store is not public. And there where we see a challenge, if you are coming in from a client, again, going back to the trust structure, how does the client have a capability, a cookie, something that enables them to access an object, unlike the case that we have in the OS pool where we manage the thing end to end, and when a request is being generated, we can somehow provide it with the right cookie token, whatever the name is. And there is another element in the case of a notebook, is if we want to monitor, collect data, collect anything, we are using quite a bit of the OS pool infrastructure to move all the usage records to Elasticsearch and then report it. When we have who collects the data and how is the data moved around for monitoring purposes, it's also an open question.
We will take one more, then I couldn't say corner us in the coffee break and then not
Yeah,
provide you
I
guys with
actually
coffee
have
breaks.
there's a question from Zoom from Amy Pound at the NSF. She says, nice talk. If I want to share a data set using OSDF, what are the steps I must take?
Yeah, so there is on our website a little or help share on the OSDF. I would love to get to the point where it could be completely automated, but right now, if you click on the button, you end up talking to Christina's team, and we start to ask about what you start the facilitation process. Make sure that we understand what you're trying to accomplish, and make sure it's a good fit. There are some things that we can't really take, like say PHI. So that's if you have medical HIPAA data, then that's our first line of defense to say, nah, this is not the right infrastructure for you. And then, as Frank was talking about, we have options where we can do a lot of the technical work. We can provide services. We can do the integration, or you can download the software and install, and we still have to approve and agree to let you in. But we have some combination of hosted options and combination of on-prem, do-it-yourself type options. So there's being a young project, there's still lots of work to do in automation and reducing the number of steps. But Christina's team will take you through it.
All right. Thanks, Brian.